For question 2 in worksheet 14, let's say that part 1 says you have 2 moles of hydrogen atoms in the ground state. So how much energy would that mean we need to have in order to transition all of the hydrogen atoms from the ground state to n equals 6? So whenever you're talking about a hydrogen model and you're looking at the energy of transitions for that, you should automatically think Bohr equation. So for the Bohr equation, you have your change in energy equals to this constant here, times 1 over nf squared minus 1 over ni squared. Nf here means the final transition state, and ni here means the initial transition state. So given what we have in the problem and given the Bohr equation, we can start plugging in for some variables. So here, it says that it starts from the ground state and reaches n equals 6. So that means my n initial is my ground state, and when I'm in my ground state, my n always equals to 1. So I have 1 here, and when n equals 6, that is my final transition state, so I have 1 over 6 squared here. And when I do the calculation, I get 2.240 times 10 to the negative 18 joules. And this energy here refers to 1 electron transition between n equals to 1 to n equals to 6. So it is per hydrogen atom because there's only 1 electron in 1 hydrogen atom. So, however, we're not done yet because it's asking for the energy required for 2 moles of hydrogen atoms. So now I have to figure out what that is for 2 moles of hydrogen atoms. So using this number that I have here, 2.240 times 10 to the negative 18 joules, I multiply it by 2 moles of hydrogen atoms, and I know that for every mole of hydrogen atoms, I have 6.022 times 10 to the 23rd hydrogen atoms. This is Avogadro's number, and I am getting 2.55 times 10 to the 6 joules.